Okay. So when you are converting, so the implicit conversion, this is the flow. Okay. Byte. So you can assign to short. Short you can assign to character. Character you can assign to integer easily. Integer you can assign to long. Long you can assign to float. But here also again you will get a problem. So long you cannot assign directly to float because of long is this is the wrong. I think this is to root this. So this can root here. Here also, if you try to do, you will get a issue. So you can course go the short to a double, that you can possible. Short you can assign to double, right? You can see here. Double number 1, 8.5. See, that is the problem here. See, you need to do a typecasting. That means a double you are converting into integer format. See, the left side, this is the, so left side is number 2 data type is integer. But number 1 data type, what is the number 1 data type? Double. So this is a different data type. Number 2 is a different data type. So that's why you'll get a type mismatch error here. To solve that, so you need to convert number 1 also to the same as the left side. That is integer. So this is called typecasting. So now in the 8.5, so what is the number 2 value you will get here after converting here, typecasting?
8.
8 you will get. Because integer mean the 8.5 integer is in 8 only, not 0.5. So this is the decimal after whatever is, that's a decimal values. So this is called typecasting. So the process of converting one data type or a class or interface value to another data type value, class or interface value is called typecasting. So what is the definition? So it's the process of converting one data type value, class, interface value into another data type, class, or interface value is called typecasting. So now see, double data type I'm converting into integer. So left hand side and right hand side same data types are there. So you can avoid a type mismatch by doing a typecasting. Typecasting can be done on the primitive data types. Typecasting can be done on the non-primitive data type also. So in Selenium, you will do non-primitive data types typecasting, like interfaces. So that's why I'm giving a heads up here itself, but I'll show you there. So this character cap left and see, now you're see character, what is the memory size? 16-bit. 16-bit will fit easily into 32-bit, right? So you won't get any issue. So why you won't get any issue is, let me show you that. The reason for that is, so here I need to typecast it. What is the typecasting here we need to do? So put the right hand side variable before and write the left hand side data type. What is the left hand side data type? Integer. You are converting double to integer. So now you can put. So I value is plus sign. So that's the one. So typecasting, you can do that. See, is the so implicit. I'll write this one is implicit type conversion. And this one is explicit type conversion or typecasting we call this. So please, these are very, very important, all these basics. So how strong you are with the basics, that's makes it matter. See, 10.4, but when I converted explicitly to integer, that is called typecasting. So now you will get a only 10. So clear, Sanjit? How are you catching? All these are very important.
Yes, sir.
So if you have any doubts, and so at least this time you have to make some effort, okay? So you have to plan it accordingly. Because 1 week you have time. So every day make some progress. That's I want to see you. Again, you should not miss the rhythm. Okay?
Yes.
Yeah. See, and one more I want to show you. This is a very implicit type conversion here. But see, there's character. I want to tell one more thing before going for that example. So ASCII table. So you all aware of this ASCII table, right?
Yeah, 65A, 66B, 67.
Yes. So every character has a one inbuilt number. Inbuilt number will be there. So every character has an inbuilt number. So that's integer number, basically. See that.
Even they have some special characters as well.
Yeah, I'm just, yeah, here it is. You can see that. See, capital A is going to have 65 integer number inbuilt. So when you assign this character to integer, automatically this integer number you will get. That's the advantage of this characters. Okay, so small a starts with a 97. 97 to 122. So capital A starts with a 65 and capital Z is 90. So any character you want, say it's a 0, it is 48, the ASCII code. So like this ASCII codes are assigned when assign the character to integers or anything, you will get that integer number. Now see character capital F. So what is a capital F ASCII code? 70. So that means when you assign, so character is 16-bit of memory, right? 16-bit of memory it occupies. Sorry. 16-bit of memory. But what is the integer memory size? 32. So these memory sizes you need to remember. So easily you can fit, right? 16-bit you will fit easily in 32-bit, right? So there is no memory space issue for you. So that's why. So you have to make sure so that automatically the character will be converted into integer. That number is going to have. So that number, the F ASCII code number. So you will get a 70 number. See that? 70. So this is the implicit or explicit? What type of type conversion is this?
Explicit.
How?
It
Are
is
you doing forcefully here?
No, implicit. It is converting
It's
from
automatically happening, right? Automatically converting, right?
Yeah.
So that means implicit. This is the implicit type conversion. Bhavya, are you getting?
Yes, Ramesh. Yeah.
So why it is implicit? Because internally it is converting to this character to integer. Because this has a ASCII code, for every character has a ASCII code number. Automatically converted. Automatic conversion means it's an implicit type conversion. So if you do like this, explicitly you are converting. This is the explicit
manual
type conversion. So this is also called typecasting. Okay. So this is the typecasting we call this. You are forcefully converting this. That's why it's explicit. Sorry, I'm a typo. Explicit type conversion or typecasting. Please, if you don't know, if you have a doubts, please ask me. I'll give more examples. Okay. So that's very, very important. See, I have given a lot of examples here also. See, the Boolean data type has only two possible values, true or false. Use this data type, simple flags, and to track the conditions, you can use this Boolean. So Boolean B equal to true, Boolean B1 equal to false. So default value for the Boolean is false. The default value, if you don't declare what is the Boolean default value, you will get a false only by default. X equal to 20, Y equal to 10. And again, I'm just making this to remember one more time, assignment operator, comparison operator. So there is a conditional operators, greater than, less than, greater than or equal to, less than or equal to, and all this will generate a Boolean value. Between numbers, if you use conditional operators between numbers, the result will be a Boolean value, that is true or false. See, I'm using, so in between numbers, these two numbers in between, I'm using these conditional operators. So what is the result I will get? A Boolean value. All this, make a note, these points are very important. See that? So X greater than Y. I'm saying 20 greater than 10. True or false?
True.
True. So true is type Boolean. That's why. So this expression output is a Boolean. So that's why B2 contains Boolean value. That data type is a Boolean. Now X less than Y. That means 20 less than 10. False. So false will store in B3. X double equal to Y. 20 double equal to 10. So true or false?
False.
False. So again, the false will store here. So this false is a Boolean type. I'm declaring this B4 as a Boolean data type. So int I equal to X plus Y. It's 20 plus 10, 30. So it's an integer. That's why I declared I as an integer. Because my output is integer. That's why left side I declared integer. There is a logical operators. Logical and, logical or, logical not equal. So when you apply these logical operators, so between two variables in between, and the result will be Boolean value. See that? So variable 1 value true and variable 2 value is true. The output is true only. So all these tables are very, very helpful when you are making logical statements. This will help you. So and case, you remember, both variables are true, the output will be true. So one variable is true and other variable is false, the output is false. And one variable is false and other variable is true and false only will get. So in this and case, when you will get a true, both variable values are true, then only you will get a true. Remaining all cases, it is a false only. That's and. When there is a or case, or means any one is true and you will get a true. Any one is true, you will get a true. So true or true, true. True or false, true. False or true, true. False or false, false. So in this case, both are false only, it will become false, the output. Otherwise, all the cases you will get a true only. And these tables are very important. See that? So not equal means you are just comparing. See, variable 1 is true, not equal to false. Right? That's a true. You will get a true. True not equal to true. False. Because true equal to true. False not equal to true. Right? True. False not equal to false. False. False equal to false. But we are making not equal. False. So all this is so other tables very, very helpful. And character I already told, and it is used to store a single character. And so I already mentioned this. Integers we covered already. So nothing to explain here. And I explain very clearly here why we will get a type mismatch error. One reason is left hand side and right hand side data types mismatch is there, is not same, then you will get a type mismatch. So left hand side variable memory size is smaller than right hand side variable memory size. That time also you will get a type mismatch error. These are the two occasions you will get a type mismatch error at compile time. So how to solve this type mismatch error? Either implicit or explicit type conversion. So typecasting means, just now I told you, process of converting the value of one data type, class or interface into another data type. Class or interface is called typecasting. See this data type variable name equal to a bigger memory variable value, and so parenthesis inside you write this data type. So this value will be converted automatically here. This is the explicit type conversion. So these are all explicit type conversion I am doing. So this is also called typecasting. See now here you see that int I equal to 50. So now I am assigning I to short. So what is you will get here a type mismatch error here. So why you will get a type mismatch error here? So why you'll get a type mismatch error here?
So that will be a memory mismatch.
So both are the same data type, right? So that is one rolled out. Now the memory issues, right? So what is the integer memory size?
32-bit.
32-bit. What is the short memory size?
16-bit.
What is the short memory size?
32-bit.
No.
Short is 13. 16.
Short.
Short
16.
is 16, int is
16.
32.
But this one is a 32 and this one is a 16. Will it fit as this is copying, right? This is you're copying into this one, right?
Yes.
When you're copying 32-bit into 16, will it fit?
No.
No.
That's why your memory mismatches here. Even though same data type, memory mismatch. That's what I told here. When you are, see this definitions, very carefully observe. Left hand side variable memory size is smaller than right hand side variable memory size. Here, left hand side memory size is smaller than the right hand side. That's why you're getting a type mismatch error here. See? Clear? So to solve that, you do a typecast, add cast to short. So I'm converting this explicitly, I'm converting integer to short. So this is the explicit conversion. So now short value is going to be S1. Okay, so that's it. So these are the values. You can see same. I have given some more examples. Please go and practice these things. So this is the another one. Let me explain here. See, float F. Okay. So this is the another one I want to show you. This is the specific type. So even though here, you see this. Now, can you tell me why you are getting a type mismatch error here? What is the read that type mismatch cannot convert from float to integer. Now F is a float. Float you cannot convert into integer, right? Both
No.
are different data types. What is the memory size of float? Hmm?
64.
Oh no, 32-bit. And integer also
32-bit.
But memories
Zero.
are same, right?
Zero memory. You don't have memory to save.
You don't have memory issue. Now, what is the memory here reason for type mismatch?
declaration F at the last on the float.
Oh, read this again. Left hand side and right hand side data type is not
Same.
same. Is it correct, right? Not same, right? Left hand side and right hand side?
Yeah, you have given
Left hand
integer.
side is
and
a
just
integer and right hand side is a float. Different data
FL.
types. So you have to convert a float into integer. Both sides should be same. So that is the explicit type conversion. I3. See that? You got only 3. So that's another example, good example for this one. And I already shown when you don't need a typecasting, it's all I already told, right? When the right hand side memory size is small and left hand side memory size is more, you don't need a anything. Okay, so that's it. And I just want to stop here. Otherwise it's going to be vast.